powers of powers. Now, some teachers will say all you do is add the powers or maybe multiply the powers. But your job is to remember whether it's an addition or whether it's a multiplication. I don't teach it like that. I teach it like this. And this is just a made up example. X squared to the power 3, I would make you write it out by hand. X squared multiplied by x squared multiplied by x squared. Okay, this way you don't have to remember any silly rules. You just have to know what x squared looks like or x cubed looks like. In your mind's eye, you would also see x squared as x times x. I don't mind if you don't write this line out. Okay, each x squared is x times x. Squaring just means multiplying by itself. And the solution, or the simpler way to x squared all cubed, is x to the power 6. There are 6 x's multiplying by themselves. Okay. Increasing the powers, x cubed to the power 4. Okay. I'll ask you to think, what does to the power 4 mean? It means multiplying it by itself 4 times. So it writes x cubed multiplied by x cubed multiplied by x cubed multiplied by x cubed. In your mind's eye, you will see this as x times x times x, and there happens to be 12 x's multiplying by themselves. And I've already got, can you just do 3 times 4? Yes, you can, but in the middle of the exam and you forget 3, oh, is it adding them or do I multiply them? You think of it like this. If I just teach you a rule to do, you'll forget the rule. That's why we have imagery of apes and baboons, and we also have what the heck does a square mean or a cube mean. It means multiplying itself either by itself twice or 3 times or 4 times, etc. Okay, let's find a hard one. I'm going to look at 12a. Can you see where 12a is? It reads x to the power 6. So I'm throwing in another layer here. I'm looking at a fraction with powers in it, and then the whole fraction is cubed. That's a 3. Again, what does cubed mean? It means multiplying itself by itself 3 times. x6 over x4 multiplied by x6 over x4 multiplied by x6 over x4. If you were to have, this is just a side 3/4 multiplied by 2/4, say, you multiply across the top line to get, and you multiply across the bottom line. It's no different in algebra. You multiply along the top line, you multiply along the bottom line. In your mind's eye, you'd see that as 6 x's will be multiplied together. Another 6 there, another 6 there. Okay, how many x's? How many x's on the bottom? Okay. This can be simplified. Remember, this is the old kitchen whiz type of fraction where everything on the top line is multiplied and everything on the bottom line is multiplied. Hence I can do some cancelling. I can cancel 12 of the x's with 12 of the x's. I'm left with 6. Answer, x to the power 6. One more problem, and that's from question 13. No, I'm going to do 12e and then I'll move to 13. Here's 12e. Okay, simplify. Looks complicated, it's not. Take it a step at a time. I think I just want to show you something also as an aside. If you have, say, 3/4 squared like this, that can be written as 3 squared over 4 squared, or 9, what did I do there? 4 squared is 16, right? Yeah, it looks like 49. I don't know how I did that. Notice that the square can work on the top line and then the bottom line. It's no different in algebra. The square can work on the top line and then the bottom line. 12x squared, that must all be squared. And 3x, that must all be squared. Okay? 12 squared. 12 12s. X squared. X squared squared. Whoops, 4. Just tricking. 3 squared. 9. And then x squared becomes x squared. This, again, is the kitchen whiz scenario, where everything is multiplied by everything. Therefore, I can do some cancelling if... Yep. So, does 144 go into 9? No, it doesn't. Not at all. But the x's can simplify down. There's 4 of them on the top and 2 of them on the bottom. Therefore, we're left with 2 on the top. 4 gets reduced down to 2. Okay, and there's my solution. 144x squared divided by 9.
16, sir.
16.
16 goes in.
Thank you. So I could simplify this down again to 16x squared. Obviously, 144 divided by 9 is 16. Okay, question 13. Watch closely. You might not have seen this before. Question 13 is the square root of 64x squared. That can be written as the square root of 64 multiplied by the square root of x squared. It's the same type of theory, I suppose, as the squaring and the division, it doesn't matter what order you do things. Okay, so those two things are the same as are those two things. Square root of 64. Square root of x squared. Oh, here's a tricky one. Number F, letter F. 13, that was 13a. Here's 13f. Four. Okay, can be written as square root of 4, which we all know, multiplied by square root of 16, which we won't all know. Answer 2 x to the eight. How did I know it was 8? Okay, here's another way of explaining it. New slide. Watch this. X squared, square root of x is equal to this. Okay. If you take something to the power of a half, they are the same thing. So square root. That previous problem, okay, x to the 16 is like that. Now some of you are thinking, all you do is multiply the powers. Well, exactly. What's 16 times a half? 8.